Hello, statistics students. Uh, I have to take my kids to a dentist appointment, so I am not able to be there today. But there is one small thing I would like you to learn and to remember from today's lesson, and it's this thing called an alpha value. So we've been doing these one proportion z tests, right? And we get our p-value. And I've been saying if this p-value is too big, then we don't reject the null. If the p-value is too small, we do reject the null. But what's too big and what's too small? Well, that value, the limiting value, is called an alpha value. All right? So that is called alpha. This is your boundary for our p-value. What's too big and what's too small. All right. Now, and this is just simply given to you. All right. We'll talk about I think in the future about where this number comes from and why you might change this number, but it is going to be given to you. I'm going to give you the boundary to reject or fail to reject. Okay. So some common alphas. Now, alpha, here is the Greek letter alpha. It's the Greek letter A. The fish. Ah, the fish. So some common alphas are, the smallest one is 0.01. 1% is a common alpha. Another alpha that's common is 0.05, and the other one, the alpha is 0.10. 10%. Those are the three most common boundaries we use to either reject or not reject. Okay? So again, if your p-value is small, you reject. How small? These are your boundaries. All right, let's do a quick example here. You'll see it's pretty easy. This just helps you make the decision to either reject or not reject. Alrighty, a recent study suggested that 77% of teens have texted while driving. All right, as an up and coming statistician, you want to test this with your own sample survey. All right, just stopping right there, I already know what my null hypothesis is going to be. Right? Our null is what we think it is before our survey. So we think the proportion is going to be 77%. All right, and we're going to test this. Here it is. It's given to us at the alpha 0.05 level. All right, that's just always going to be given to you. That's our boundary. You think the proportion might be different, but you don't know which way. All right, I realized we hadn't done one of these. So our alternative, we don't know if the proportion is going to be greater than or less than 77. We just want to see, is it different? Is it something other than 77? Is it not equal to? All right, we have our null and alternative. So now we take our sample of 80 students. All right, we get 80 students, and 68 admit to texting while driving. All right, so our p-hat, our sample proportion, is 68 out of 80. All right, so I'm just curious. 68 out of 80 is 85%, 0.85. Well, now, I've been saying this over and over, but I'm going to say it again. We have some evidence that it's not 77, right? 85 is definitely not 77. We have some evidence it's not 77. Is it convincing evidence? So we do our one proportion z test. So that, again, is done on your calculator. Now, I don't have a nice emulator for your exact calculator, but hopefully you can get to the one prop z test. This one has it as well. I go to my tests, and I go to one prop z test. It looks different than yours, but it's the same name. So find your one prop z test. This pretty much looks the same as yours as well. My null is 0.77. My number of successes right here is 68. N is 80. And this time I'm going to choose the not equal to one. So not one of the alligator signs, but the not equal, because going into this, we didn't know if it was going to be bigger or smaller. All right, so we're going to calculate this. And it gives us our p-value of 0.089. My p-value is right there. And so now we have to make the judgment. Is that p-value big or is it small? Kind of hard to judge, but now we know what to judge it against. The problem said our boundary was 0.05. Essentially, if our sample was in the 5% rarest of samples. But it wasn't. Our p-value is bigger than that number. So with a p-value of 0.089, which is greater than alpha, all right, our p-value is too big. It was bigger than our boundary line. We fail to reject the null. All right, we do not have enough evidence to say the proportion of teens that have texted while driving is different. We didn't know if it was more or less, huh? Different than 77%. All right, we don't have enough because our p-value was too big. How did we use what boundary did we use for too big, too small? This new thing called alpha. Hopefully that makes our decisions of too big, too small a bit easier. All right, I would like you to practice that a bit. So there's a Khan Academy video to watch so you can listen to him explain the same thing. And then there are some practice problems after that. Do those two Khan Academies and you can call it a day. I'll see you tomorrow, everyone.